In the heart of the Scottish Highlands lies a lake that seems almost alive, still on the surface, yet whispering with secrets beneath. For centuries, people have sworn that something moves in these dark waters, a shadow that rises, ripples, and disappears. Over 1,000 eyewitnesses, dozens of photographs, even DNA tests, and still, no one agrees on what they've seen. This is the real story of the Loch Ness Monster, a legend that refused to drown, even when the world tried to sink it. But before we go chasing the legend through time, we need to understand the creature itself, the one that started it all. Who or what is Nessie supposed to be? Eyewitnesses across generations describe a creature both mesmerizing and impossible. A dark form that moves just beneath the surface, rising and sinking with deliberate calm. Most reports agree on the same features: a long, slender neck, a small head, and a large, rounded body, sometimes with one or more humps breaking the surface. It moves with an almost effortless glide, as though the loch itself parts for it. Many describe the creature's skin as dark gray or greenish brown, coarse and textured like that of an elephant or a seal. When it surfaces, it appears wet, glistening in the weak highland light. Some witnesses claim to have seen its eyes, small, black, and steady. Watching before it slipped back beneath the surface with barely a ripple, its sheer size is what makes it unforgettable. Estimates vary wildly. Some say 10 feet, others over 40. But the shape, the way it rolls through the water in smooth, linked arcs, has made one theory more enduring than any other: that Nessie might be a surviving plesiosaur. Plesiosaurs were marine reptiles that lived during the Jurassic and Cretaceous periods, between 200 and 65 million years ago. Their bodies were built for stealth: broad barrel-shaped torsos, 4 powerful flippers for propulsion, and necks that stretched up to half their total body length. The largest species grew over 30 feet long. Their anatomy, reconstructed from fossils, suggested a unique form of movement. Instead of side to side like a crocodile, plesiosaurs flew underwater, moving their fins in sweeping figure-8 motions, like wings. The result was smooth, gliding motion, not unlike what Loch Ness witnesses have described for decades. But if, for a moment, we imagine it really was a plesiosaur, science raises some difficult questions. These ancient reptiles were air breathers. They would have to surface every few minutes, leaving unmistakable ripples or splashes. Their bones tell another story too: tightly interlocking vertebrae that made the neck far less flexible than people imagine. So, if Nessie isn't a relic from the age of dinosaurs, where did her story truly begin? The earliest trace of Nessie's legend doesn't begin with tourists or cameras. It begins with a monk. In the year 565 AD, an Irish missionary named St. Columba was traveling through the Scottish Highlands, spreading Christianity across a land still ruled by superstition and stories of spirits that haunted rivers and glens. When Columba reached the banks of the River Ness, he found a group of villagers burying a man. They told him the man had been attacked by a water beast while swimming across the river. Intrigued, or perhaps testing his faith, Columba turned to one of his followers and ordered him to enter the water. The villagers protested. They begged him not to, but the man obeyed. As he swam, the dark water broke open. Something surged to the surface. A great shape moving fast, throwing up waves as it came for him. Columba stepped forward. He raised his hand, made the sign of the cross, and shouted for the creature to stop. And then, silence. The beast froze mid-charge, sank back into the river, and disappeared. That account, written a century later in Vita Columbae, became the first written record of a monster near Loch Ness. For over a millennium, the loch remained mostly silent, hidden deep within the Scottish Highlands. It stretched for 22 miles between steep hills cloaked in pine and fog. Its water was dark, almost black. Even when it was calm, few dared to cross it to avoid any strange and eerie encounters. Then came the 20th century, and with it, the road that changed everything. In 1933, engineers completed the A82, a new highway that wound along the northern shore of Loch Ness. For the first time, travelers could drive through what had once been one of Scotland's most remote valleys. That same year, a local couple, George and Aldi Spicer, reported seeing something they could not explain. While driving along the new road, they watched as a large, dark creature crossed in front of their car. They described it as having a long neck, a massive body, and an awkward rolling motion as it dragged itself toward the loch. It vanished into the water within seconds. The Spicer story appeared in the Inverness Courier, a small regional paper. From there, it spread like wildfire. Other locals stepped forward with their own accounts. Within weeks, the world's newspapers had picked up the story. Reporters poured into the highlands. Photographers waited on the shores from dawn till dusk, hoping for proof. In April 1934, a photograph appeared on the pages of the Daily Mail. It showed what looked like the long, curved neck of a creature rising out of the water, smooth, graceful, and unmistakably alive. The man who took it was said to be a London surgeon named Dr. Robert Kenneth Wilson Calm. Respectable and trusted, he wanted nothing to do with fame. When journalists pressed him, he simply said he had photographed something in the loch. The image spread like wildfire. Within days, it was printed in newspapers across the globe. To millions, it was proof at last that the monster of Loch Ness was real. Tourists flooded the highlands, scientists debated on radio, and the legend now with a face was unstoppable. But behind the image, the truth was murkier than the loch itself. For 60 years, that photograph stood as the most famous piece of evidence for Nessie's existence. Until, in 1994, the secret finally surfaced. The picture wasn't of a giant creature at all. It was a toy submarine fitted with a model head and neck, built by a man named Christian Sperling, the stepson of Marmaduke Wetherell, a big game hunter who had once been ridiculed by the same newspaper for failing to find the monster Wetherell had sworn revenge. And his fake photo, passed to Dr. Wilson to give it credibility, fooled the entire world. By the time the truth came out, it didn't matter. Even when exposed as a hoax, people didn't stop believing. Because now, Nessie wasn't just a legend. She was an icon. By the mid-20th century, the world had made up its mind. Something was in Loch Ness. Scientists, journalists, and explorers all wanted to separate myth from fact. One of them was Tim Dinsdale, an aeronautical engineer who arrived at the loch in 1960 armed with a 16mm camera and quiet determination. From the opposite bank, he spotted something moving steadily across the surface, dark, smooth, and leaving a wake that looked alive. He filmed for barely a minute, but the footage ignited global fascination. Analysts at Britain's Air Reconnaissance Unit studied the film and declared the object probably animate. Decades later, digital reanalysis suggested it was more likely a small boat, a reminder that even the camera can be as deceptive as the eye. In 1955, before Dinsdale bank manager Peter McNabb had captured what seemed like two great humps moving near Urquhart Castle. Half a century later, in 2000, postman Bobby Pollock filmed a dark object moving erratically. Closer inspection revealed what looked like the strokes of a swimmer's arms, possibly a diver in a black wetsuit. Again and again, the lesson repeated: our eyes and even our cameras are fallible. So, if Nessie was only a myth, why did the results initially say otherwise? The answer may lie in the strange nature of Loch Ness itself. It is a body of water designed by geology to deceive. The loch stretches more than 22 miles through a glacial trench carved by ice and fault lines, plunging to 754 feet at its deepest point, deeper than the North Sea. Its water is stained dark brown by peat, the decayed plant matter that seeps in from surrounding hills. This organic tint doesn't just color the loch, it absorbs light almost completely. Scientists use a simple white disc called a Secchi disc to test visibility. In clear lakes, the disc can be seen sinking 30 feet or more. In Loch Ness, it disappears after barely 9 feet. Beyond that, everything is swallowed in darkness. Even a large animal would vanish just a few meters below the surface. Cameras and sonar both struggle in these conditions. Light can't penetrate, and sound waves bounce unpredictably between temperature layers and suspended silt. The loch's great depth and cold, heavy water create thermoclines, invisible boundaries where warm and cold layers meet. These layers bend light and sound, distorting images and returning false echoes. Here, even physics conspires with imagination. Loch Ness is not just deep in water, it's deep in illusion, and this explains all the pictures and illusions created over time. By the 1960s, belief had met its challenger, technology. If the human eye could be fooled, perhaps the machines could not. One of the earliest serious efforts came when a group calling themselves the Loch Ness Investigation Bureau set up along the shores. They brought telescopes, still cameras, and for the first time, primitive sonar systems, sending sound pulses into the dark water. They scanned day and night, listening for echoes that could hint at something large and moving. Their screens flickered with anomalies, shapes that glided below the surface and vanished. Whether they were creatures or artifacts, one thing became clear: the loch wasn't empty. Then, in 1975, an American team led by Robert Rines brought a new twist: underwater cameras triggered by sonar. Whenever the sonar detected movement, the camera snapped a photo. One of the resulting images showed what appeared to be a diamond-shaped flipper attached to a bulky body. The photo spread across the world, reigniting hope, but also sparking scrutiny. Later analysis suggested that the image might have been distorted by debris, lighting, and murky water, showing how difficult it is to draw firm conclusions from such material. A decade later, in 1987, came the most ambitious expedition yet: Operation Deep Scan. 24 boats equipped with advanced sonar and organized in a grid across the loch attempted to map the floor of Loch Ness in one sweep. Their mission was to leave no stone unturned, no swirl of water unanalyzed. The result was 3 large unidentified sonar contacts. These targets moved in ways inconsistent with known fish or debris. Headlines announced the monster had been found. But the enthusiasm dimmed under scientific review. Experts concluded that the echoes could have been caused by drifting logs, sediment plumes, or pockets of gas rising from the loch bed. In an article describing Deep Scan, one writer observed, "While unexplained and unlikely to represent fish, these contacts were probably debris or thermal effects, nothing that can be interpreted with confidence as a giant animal." As sonar and optical systems improved through the 1990s and each expedition returned with more data, but no definitive monster. By the early 1990s, the legend of the Loch Ness Monster had become a global obsession. But after decades of rumors and photographs, scientists now wanted hard data. That search led to one of the most detailed studies of the loch ever attempted. Between 1992 and 1993, researchers carried out Project Urquhart, a hydrographic survey that used millions of sonar soundings to map the lake floor in unprecedented detail. The results revealed a vast, uneven landscape with trenches, shelves, and pockets where sonar signals sometimes bounced and split, creating false images. Yet amid the noise, there were still strange, strong mid-water contacts, blips too large to match known fish species. Nearly a decade later, in 2003, the BBC mounted one of the most ambitious hunts to date. Using more than 600 sonar beams and satellite-guided navigation, they swept the loch end to end. The verdict was clear and simple. No creature of any substantial size was detected. It was a blow to believers, but also a reminder of how difficult the search really was. In a loch this deep and murky, even advanced sonar can be fooled by layers of temperature and sediment. And yet, the mystery persisted. Throughout the 2000s and 2010s, tour boats and research vessels continued to log unexplained sonar hits. Large, solid shapes moving hundreds of feet below the surface. One of the most publicized came in 2014 when a cruise vessel, the Jacobite Queen, recorded a long, smooth echo unlike any known fish pattern. The reading was genuine, but the explanation, like the loch itself, remained cloudy. Then, in 2016, technology delivered an unexpected twist. A Norwegian survey drone scanning the loch for geological data found what appeared to be a 30-foot monster resting on the bottom. When divers went down, they discovered the truth. It was the sunken film prop from the 1970 movie The Private Life of Sherlock Holmes. A perfect symbol for the legend itself, a real discovery, but the wrong creature. By 2018, the world had spent nearly a century chasing shadows across the loch: cameras, sonar, submarines. Every tool of the modern age had been lowered into those dark waters. And yet, the mystery refused to yield. That year, a new kind of investigation began. Not with boats or binoculars, but with DNA. Professor Neil Gemmell from the University of Otago in New Zealand led the most ambitious scientific survey ever attempted at Loch Ness. His team collected over 250 water samples from the sunlit shallows to the deepest, coldest trenches. Each sample was filtered, separating fragments of environmental DNA and microscopic traces left behind by every living thing that passes through water. The theory was simple. If anything large lived in the loch, its genetic fingerprints would be there. And the results were extraordinary. There was no trace of any prehistoric reptile, no giant amphibian, no shark, seal, or whale. Every exotic explanation of the past century was ruled out in a single sweep, but something else appeared in abundance. EL DNA found in nearly every sample, from every corner of the lake. The sheer volume of eel DNA stunned the team. Loch Ness, it seemed, was teeming with them. Professor Gemmel's conclusion was cautious, yet profound. Perhaps the answer had been swimming among us all along. The giant eel hypothesis wasn't new, but for the first time, science had given it weight. It explained the shape that people described for centuries: long, flexible, and serpentine. It matched the motion seen in countless eyewitness reports, the rolling, snake-like undulation of something alive but unfamiliar. And it fit perfectly with the biology of the loch itself: deep, cold, and rich in prey, small enough to sustain eels for decades. European eels are born thousands of miles away in the Sargasso Sea, carried by ocean currents as tiny glass larvae before reaching lakes like Loch Ness. Once there, they can live quietly for 20 to 30 years, growing larger and thicker each season. In rare cases, genetic variation and environment can trigger gigantism, producing creatures far longer than what's considered normal. In the loch's dark, peat-stained waters, even a 6-foot eel could look monstrous. A brief glimpse of its body twisting near the surface might appear as multiple humps. A single rise, followed by a ripple, could seem like a creature diving into the depths. It was an explanation that answered almost everything. Why Nessie seemed serpentine, why she appeared and vanished so quickly, and why no bones or remains were ever found. The eel left no skeleton behind. It came and went with the currents. Still, not everyone was convinced. Some argued that eyewitnesses had seen something far larger than any eel could possibly be. Others pointed out that while eDNA can tell what species exist, it cannot reveal how big they are. There was no proof of a monster-sized eel, only overwhelming evidence that eels dominated the loch. Yet even skeptics admitted one thing. Of all the explanations proposed in 100 years of searching, the eel was the first that made sense in both science and spirit. It didn't destroy the legend, it humanized it, a living creature, ancient yet real, magnified by fog, distance, and imagination. By 2024, technology had evolved far beyond anything the early monster hunters could have imagined. Theories had been tested, photographs had been exposed, DNA had spoken. And yet, the world still wasn't ready to let Nessie go. That year, an international team of researchers returned to Loch Ness armed with autonomous underwater drones, multi-beam sonar arrays, and LiDAR mapping, equipment sensitive enough to read the ripples of a fish fin hundreds of feet below. Their goal wasn't to chase myths anymore, it was to redraw the map of the loch itself. What they found surprised even the skeptics. For nearly a century, scientists believed Loch Ness reached a maximum depth of 754 feet, but new sonar imaging revealed a hidden trench, a deep, narrow abyss plunging close to 889 feet, making Loch Ness even deeper than previously recorded. Inside that trench, the drones also picked up something unexpected. Slow, pulsing shapes appeared on the sonar, smooth, elongated, moving just above the silt. They didn't match the known signatures of salmon, trout, or sturgeon. Some readings resembled large eels, others looked like sediment shifts or cold water currents flowing between thermal layers. The data baffled analysts. Were they looking at living creatures, or just the loch itself, moving and breathing through its dense layers? Basically, the loch's thermoclines, or the invisible layers where warm and cold water meet, bend sonar waves like glass bends light, creating echoes that seem alive. A single school of fish can appear as one massive shape. Gas bubbles rising from decaying vegetation can register as something solid. Even the loch's steep, jagged floor can reflect signals that mimic slow, rhythmic movement. Still, the readings were real, and for those who watched them flicker on the monitors, the feeling was unmistakable. That old, familiar pulse of possibility. For scientists, it was another reminder of how little we truly know about this ancient valley. In early 2025, the legend of Nessie stirred again. At Dora's Beach, a visitor captured a photograph of what appeared to be a large, dark shape gliding just beneath the still surface of Loch Ness. The sighting lasted several minutes, long enough for the observer to describe it as a solid form, darker than the surrounding water, before it slowly vanished. The weather that day was calm, the water mirror still, and the photograph soon became the first officially logged potential sighting of the year. A few weeks later, the Quest Festival 2025 brought researchers, engineers, and enthusiasts from around the world back to the loch. This time, they came not with binoculars or old sonar, but with autonomous underwater vehicles, high-definition ROVs, and multi-beam sonar mapping tools capable of scanning depths that had never been explored. Their mission was not to find the monster, but to study the environment that had kept its mystery alive. What they found was unexpected. In the darkness nearly 600 feet down, one of the ROVs stumbled upon a camera trap cable and housing, lying undisturbed on the silty floor. It dated back nearly 50 years. Equipment originally deployed by the famous researcher Robert Rines in the 1970s. Inside, fragments of film and corroded fittings were still intact, though the film revealed no creature, but its recovery showed how little had disturbed that part of the loch in half a century. At the same time, underwater footage from the 2025 expedition revealed unusually large pike and salmon swimming in areas previously thought barren. Their presence surprised biologists. It meant the loch's food chain was richer than once believed, strong enough to sustain much larger predators. It was a finding that reopened old debates. If such large fish can thrive in these depths? By mid-spring, another sighting was logged. An observer from Urquhart Bay reported a dark, elongated shape beneath the water, moving against the wind and trailing a faint line of bubbles before disappearing. It became the second official sighting of 2025, renewing curiosity that had quieted since the pandemic years. Each of these discoveries, some tangible, others fleeting, painted a complex picture. There was still no evidence of a prehistoric creature, but the new data suggested that Loch Ness was far from lifeless. It held an ecosystem deeper and more dynamic than previously recorded, one capable of sustaining mysteries both biological and psychological. For nearly 1,500 years, something has lingered in the dark waters of Loch Ness. Not just a creature, but an idea. Generations have searched these depths with nets, sonar, cameras, and now DNA. And each time the loch answers, it answers in riddles. Every photograph explained, every theory tested, every expedition returning with more questions than proof. And yet, the legend remains. Perhaps that's because the Loch Ness Monster was never just about the monster. It's about the mystery itself. The need to believe that there are still corners of our world that refuse to be measured or mapped. That somewhere beneath the algorithms and data, there's still room for wonder. Scientists will tell you the loch's darkness can fool the eye. The layers of cold and warm water can distort sonar, bending echoes into phantoms. Even DNA can deceive, telling us what species exist, but never how large or how strange they might become. But that's the beauty of it. Loch Ness doesn't hide the truth. It reflects us, our curiosity, our imagination, our hunger to find meaning in the unknown. And that's a wrap on the mystery of the Loch Ness Monster, a legend that time itself couldn't drown. If you enjoyed this story, make sure to subscribe and dive into our videos on the North Sea and the Drake Passage, where the ocean hides even greater mysteries.